Imagine witnessing over 4 million mackerel being caught and processed every single day across the globe, with industrial fishing vessels harvesting more than 6 million tons of these remarkable fish annually. Picture processing plants operating around the clock, transforming fresh mackerel into billions of cans and frozen products that supply grocery stores and restaurants in over 100 countries worldwide. What if I told you that the global mackerel industry generates more than $12 billion in revenue each year, making it one of the most valuable commercial fisheries on Earth? Yet most people have no idea about the incredible technology and logistics behind bringing these nutritious fish from ocean to table. Welcome to AgriCraft, where we explore the fascinating intersection of traditional practices and cutting-edge technology in food production. I'm your host, and today we're diving deep into the extraordinary world of commercial mackerel fishing and processing, an industry that represents one of the most efficient and technologically advanced forms of marine food production. From the massive fishing vessels equipped with sophisticated sonar systems that can locate schools of mackerel miles away, to the state-of-the-art processing plants where automated systems handle thousands of fish per minute, we'll follow these incredible fish through their complete journey from the open ocean to your dinner table. All will be revealed in this video. The story of mackerel fishing stretches back thousands of years, with archaeological evidence showing that coastal communities have been harvesting these abundant fish since ancient times. What began as small-scale fishing with simple nets has evolved into one of the world's most sophisticated marine agriculture operations, utilizing technology that would have been unimaginable just 50 years ago. Today's mackerel industry represents a triumph of sustainable fisheries management and technological innovation. The North Atlantic mackerel fishery alone supports over 40,000 jobs across multiple countries, with vessels from Norway, Scotland, Ireland, and Iceland participating in carefully managed quotas that ensure long-term sustainability. This isn't just fishing anymore. It's precision marine agriculture that combines scientific research, advanced technology, and international cooperation to harvest one of the ocean's most abundant and nutritious resources. The economic impact of mackerel fishing extends far beyond the fishing vessels themselves. Processing facilities, canning operations, transportation networks, and distribution systems create employment for hundreds of thousands of workers worldwide. In Norway, the mackerel industry contributes over $2 billion annually to the national economy, while providing essential protein to global food markets. What makes mackerel particularly fascinating from a marine agriculture perspective is the incredible efficiency of modern fishing operations. A single fishing vessel can harvest over 1,000 tons of mackerel in a single trip, with the most advanced ships processing and freezing fish at sea before returning to port. These floating factories represent some of the most sophisticated food production facilities on the planet. The scale of global mackerel fishing is truly staggering. Japan processes over 800,000 tons annually, much of it destined for their domestic market where mackerel is considered a dietary staple. The European Union manages quotas for over 1 million tons of mackerel annually across multiple species, while maintaining sustainable fishing practices that ensure healthy fish populations for future generations. The transformation from traditional fishing to modern marine agriculture represents one of the most remarkable success stories in sustainable resource management. Where historical overfishing once threatened fish populations, today's scientifically managed fisheries utilize real-time population monitoring, GPS tracking, and sophisticated quota systems to maintain healthy mackerel stocks while meeting growing global demand for affordable, nutritious protein. Modern mackerel fishing has also embraced technological innovations that would amaze traditional fishermen. Sonar systems can detect fish schools from miles away, while onboard processing equipment can fillet, freeze, and package fish within minutes of capture. These advances have transformed mackerel fishing from a seasonal activity dependent on luck and weather into a year-round industrial operation capable of supplying consistent quantities of high-quality fish to global markets. Let's explore how these remarkable operations actually function, beginning with understanding the unique characteristics and marine requirements that make mackerel such an important commercial fish species. Understanding mackerel begins with recognizing that these remarkable fish represent one of nature's most perfectly designed marine organisms for large-scale commercial harvest. Unlike many fish species that require specific habitat conditions or complex breeding environments, mackerel thrive in open ocean conditions and form massive schools that can contain millions of individual fish. The biological characteristics that make mackerel ideal for commercial fishing include their rapid growth rates, high reproductive capacity, and natural schooling behavior. Atlantic mackerel can reach commercial size within 2 years, with females capable of producing over 500,000 eggs annually. This remarkable reproductive capacity allows mackerel populations to sustain intensive fishing pressure while maintaining healthy stock levels under proper management. Mackerel species vary significantly across different ocean regions, each adapted to specific environmental conditions and market preferences. Atlantic mackerel dominate European and North American markets, prized for their rich oil content and distinctive flavor. Pacific mackerel, smaller but equally nutritious, supply Asian markets where they're processed into everything from fresh sashimi to canned products. Spanish mackerel, larger and meatier, command premium prices in Mediterranean markets. The environmental requirements for mackerel populations include specific water temperatures, ocean currents, and food availability that create predictable migration patterns. These fish follow ancient routes that bring them close to major fishing grounds at optimal times for harvesting. Understanding these migration patterns allows fishing fleets to position themselves for maximum catch efficiency while minimizing fuel consumption and environmental impact. Modern fisheries science has revolutionized our understanding of mackerel ecology through satellite tracking, genetic analysis, and population modeling. Scientists can now predict mackerel movements with remarkable accuracy, allowing fishing fleets to optimize their operations while ensuring sustainable harvest levels. This scientific approach has transformed mackerel fishing from a hit-or-miss endeavor into a precisely managed agricultural operation. The natural diet and feeding behavior of mackerel contribute to their exceptional nutritional value and distinctive flavor characteristics. These fish feed primarily on small crustaceans, plankton, and smaller fish, creating a marine food chain that concentrates valuable omega-3 fatty acids and other nutrients. This natural diet gives mackerel their characteristic rich oil content that makes them so valuable for both fresh consumption and processing into canned products. Population monitoring systems utilize everything from underwater cameras to genetic sampling to track mackerel stock health and breeding success. These monitoring programs provide the scientific foundation for quota setting and fishing season management, ensuring that harvest levels remain within sustainable limits while supporting the economic viability of fishing operations. The schooling behavior of mackerel represents both an opportunity and a challenge for commercial fishing. Schools can contain millions of fish concentrated in relatively small areas, allowing for incredibly efficient harvesting when conditions are optimal. However, these schools are constantly moving and can disappear quickly, requiring fishing vessels to utilize sophisticated detection equipment and rapid response capabilities. Modern fishing vessels targeting mackerel are equipped with fish-finding technology that rivals military sonar systems. These advanced detection systems can identify the size, density, and movement patterns of mackerel schools from distances of several miles, allowing captains to position their vessels for optimal fishing success while minimizing wasted time and fuel consumption. As fishing vessels locate and approach mackerel schools, they deploy some of the most sophisticated harvesting technology ever developed for marine food production, beginning the transformation from wild fish to processed food products. The harvest stage in mackerel fishing represents where traditional seamanship meets cutting-edge marine technology. Modern mackerel fishing vessels are floating factories capable of locating, capturing, and processing thousands of tons of fish during single fishing trips that can last several weeks. Harvest timing in mackerel fishing depends on understanding complex migration patterns, seasonal variations, and optimal catch conditions. Peak fishing seasons vary by region and species, with Atlantic mackerel typically harvested during their summer and autumn migrations when fish are at peak condition and oil content. These seasonal patterns require fishing fleets to coordinate their operations across vast ocean areas to maximize catch efficiency. The actual catching process utilizes purse seine nets that represent marvels of marine engineering. These massive nets can measure over 1 mile in circumference and are deployed around entire mackerel schools by specialized fishing vessels working in coordinated teams. Modern purse seine operations can encircle and capture entire schools containing hundreds of tons of fish in a single set. Net deployment requires precise coordination between multiple vessels, with each ship playing a specific role in the capture operation. The main fishing vessel deploys the net, while smaller boats help position and close the net around the fish school. Modern vessels utilize GPS coordination and radio communication to execute these complex maneuvers with precision timing that ensures maximum catch efficiency. Mechanical harvesting systems have revolutionized how fish are brought aboard modern fishing vessels. Hydraulic net haulers can lift nets containing hundreds of tons of fish, while fish pumps transport live fish from the net into shipboard holding tanks or processing areas. These systems handle enormous volumes of fish while minimizing damage that could affect product quality. The processing of mackerel often begins immediately after capture, with many fishing vessels equipped with complete processing lines that can handle fish from initial sorting through final packaging. Onboard processing ensures optimal freshness while reducing the time between capture and processing that can affect product quality and value. Quality assessment during harvest involves evaluating fish size, condition, and freshness to determine optimal processing methods. Premium fish are often processed for fresh markets, while fish showing any signs of stress or damage are directed toward processing lines for canned products. This real-time quality assessment ensures that each fish is utilized in its highest value application. The scale of modern mackerel fishing operations can be truly breathtaking. Individual fishing vessels can capture over 200 tons of fish in a single net set, with the largest operations processing thousands of tons during multi-week fishing trips. These volumes require sophisticated handling systems and processing equipment that rivals land-based food processing facilities. Storage systems aboard modern fishing vessels maintain captured fish at optimal temperatures and conditions until processing can be completed. Refrigerated seawater systems keep fish at precise temperatures, while automated circulation systems maintain oxygen levels and water quality that preserve fish condition during storage periods. Transportation from fishing grounds to processing facilities or markets requires careful coordination of vessel scheduling, processing capacity, and market demand. Many modern fishing vessels can process and freeze their catch at sea, allowing them to remain on fishing grounds for extended periods while maintaining product quality for global distribution. The efficiency of modern mackerel fishing operations represents one of the most successful examples of sustainable marine agriculture, with catch rates and fuel efficiency that continue improving through technological advancement and scientific management practices. As captured mackerel move from fishing vessels to shore-based facilities, they enter processing plants that represent some of the most advanced food processing technology ever developed for handling marine products. The processing stage begins the moment mackerel arrive at shore-based facilities, where they encounter industrial systems specifically designed to handle the unique characteristics and high volumes associated with commercial mackerel processing. These facilities operate around the clock during peak fishing seasons, processing thousands of tons of fish daily while maintaining strict quality standards. Initial handling procedures at processing plants involve rapid unloading systems that can transfer entire vessel loads of fish into processing lines within hours of arrival. Conveyor belts transport fish from unloading areas through initial sorting and grading procedures that determine processing pathways based on size, quality, and intended end use. The sterilization and cleaning protocols in mackerel processing plants exceed standards found in most food processing operations. Workers undergo extensive hygiene procedures, including sanitizing showers, protective clothing changes, and health monitoring protocols. Processing areas are maintained under strict temperature controls with automated cleaning systems that sterilize equipment between production runs. Quality inspection procedures begin immediately upon arrival, with trained inspectors evaluating each batch of fish for freshness indicators, size consistency, and overall condition. These initial assessments determine whether fish will be processed for fresh markets, canned products, or frozen applications, ensuring that each fish is utilized in its optimal application. Automated sorting systems utilize sophisticated technology, including optical scanners, weight sensors, and size grading equipment to separate fish into precise categories. These systems can process thousands of fish per hour while maintaining sorting accuracy that exceeds manual sorting capabilities, ensuring consistent product quality across large production volumes. The main industrial processing steps vary significantly depending on intended end products. Fresh fish processing involves filleting, skinning, and packaging operations that preserve optimal texture and appearance. Canning operations require different processing steps, including cooking, sterilization, and hermetic sealing procedures that ensure long-term stability and food safety. Modern filleting machines represent marvels of food processing engineering, capable of processing whole mackerel into precise fillet portions in seconds while minimizing waste and maintaining optimal product appearance. These automated systems utilize computer-controlled cutting patterns that adjust for individual fish variations while maximizing yield and product consistency. Industrial machines used in mackerel canning operations include everything from automatic fish feeders to sealing equipment that can process thousands of cans per hour. These production lines integrate multiple processing steps including fish preparation, can filling, liquid addition, sealing, and sterilization into continuous automated systems that operate with minimal human intervention. Temperature control throughout mackerel processing plants is critical for both food safety and product quality. Different processing areas maintain specific temperatures optimized for particular operations, with fresh processing areas kept just above freezing, while canning operations utilize precisely controlled cooking temperatures that ensure product safety and quality. Quality control procedures continue throughout every stage of processing, with trained specialists monitoring production lines continuously for consistency, safety compliance, and adherence to established quality standards. Products undergo regular testing for bacterial levels, temperature compliance, and physical characteristics that determine final product grading. The processing of mackerel for different market segments requires specialized knowledge and equipment configurations. Fresh fish processing emphasizes speed and temperature control to maintain optimal product characteristics, while canned product processing focuses on achieving commercial sterility and long-term stability through thermal processing and hermetic sealing. Waste reduction and byproduct utilization represent important aspects of modern mackerel processing, with specialized equipment designed to capture and process materials that were once considered waste. These systems contribute to both economic efficiency and environmental sustainability while maximizing the value extracted from each fish processed. Following the intensive processing procedures, mackerel products move into sophisticated packaging and distribution systems designed to preserve quality while meeting the diverse requirements of fresh, frozen, and shelf-stable markets worldwide. The packaging systems used in mackerel processing operations must accommodate multiple product formats while maintaining the specific preservation requirements each product type demands. Automated packaging lines handle fresh, frozen, and canned products simultaneously, switching between packaging formats based on production schedules and market demands. Fresh mackerel packaging utilizes modified atmosphere systems that replace air with gas mixtures, optimized for extending shelf life while maintaining optimal appearance and texture. These packaging systems can adjust gas compositions in real time based on fish species, processing method, and intended distribution duration, ensuring optimal product preservation for each specific application. Vacuum packaging systems for premium fresh mackerel products remove all air while creating hermetic seals that prevent bacterial growth and oxidation. These systems utilize specialized packaging materials designed to maintain flexibility at refrigerated temperatures while providing exceptional barrier properties against oxygen and moisture infiltration. Frozen mackerel packaging requires different considerations, with systems designed to prevent freezer burn while maintaining package integrity during frozen storage and transportation. Automated packaging lines for frozen products can handle multiple portion sizes and package formats while maintaining consistent package weights and appearance standards. Canned mackerel packaging represents perhaps the most sophisticated packaging technology in the industry, with automated canning lines that can fill, seal, and process thousands of cans per hour while maintaining commercial sterility and long-term stability. These systems incorporate everything from automatic can handling to precision fill weight control and hermetic sealing verification. Labeling systems in mackerel processing facilities must accommodate complex regulatory requirements across multiple international markets. Products destined for different countries require specific labeling formats, nutritional information, and regulatory compliance data. Automated labeling machines can switch between label formats instantly while maintaining accurate product identification and traceability information. Cold storage facilities and mackerel processing plants maintain multiple temperature zones optimized for different products and storage durations. Fresh products are stored at temperatures just above freezing, frozen products at -18 degrees Celsius, while canned products can be stored at ambient temperatures. These storage systems incorporate sophisticated inventory management that tracks product age, quality parameters, and distribution scheduling. The distribution networks for mackerel products span the globe and require expertise in international shipping regulations, cold chain management, and product preservation during extended transportation periods. Fresh products might reach markets within 48 hours of processing, while canned products travel through conventional shipping networks that can take weeks to reach final destinations. Quality control procedures extend throughout the packaging and distribution process, with products tested regularly for package integrity, temperature compliance, and microbiological safety. These testing protocols ensure that products maintain safety and quality standards throughout their journey from processing plant to final consumer, regardless of transportation method or destination market. Traceability systems in modern mackerel processing utilize advanced tracking technology that allows individual packages to be traced back to specific fishing vessels, catch dates, and processing batches. This comprehensive traceability provides critical information for food safety management, while enabling processors to quickly identify and address any quality concerns that might arise in the distribution chain. Shipping logistics for mackerel products require specialized knowledge of international trade regulations, seafood import requirements, and cold chain management across multiple transportation modes. Different countries maintain varying standards for mackerel imports, and successful operations maintain expertise in navigating these complex regulatory environments to access premium international markets. The packaging and distribution systems represent the final critical link in the mackerel supply chain, ensuring that the quality and nutritional value built into products throughout the fishing and processing stages reaches consumers in optimal condition while meeting the logistical demands of global food distribution networks. Beyond the primary fish products, mackerel processing operations generate numerous valuable byproducts that contribute significantly to overall economic viability while demonstrating the comprehensive resource utilization possible in modern seafood processing. Fish oil extraction represents one of the most valuable byproduct streams in mackerel processing, with the high oil content of these fish making them ideal for producing premium marine oils rich in omega-3 fatty acids. Modern processing facilities utilize sophisticated extraction equipment that can recover oil while maintaining the nutritional integrity and purity required for dietary supplement and pharmaceutical applications. The fish oil processing systems employ centrifugal separation technology that can extract oil from fish processing waste while removing impurities and maintaining optimal quality characteristics. This extracted oil commands premium prices in health supplement markets, where marine-derived omega-3 fatty acids are highly valued for their cardiovascular and cognitive health benefits. Fish meal production from mackerel processing waste provides valuable protein sources for animal feed applications. Specialized drying and grinding equipment converts fish bones, heads, and processing trimmings into high-protein meal that sells for hundreds of dollars per ton to aquaculture operations, pet food manufacturers, and livestock feed producers. The processing of mackerel waste into fish meal utilizes thermal processing systems that cook and dry materials while preserving protein quality and digestibility. These systems can process thousands of pounds of waste materials daily while producing consistent grades of fish meal that meet specific nutritional requirements for different end-use applications. Fish silage production represents another valuable application for mackerel processing waste, utilizing controlled fermentation processes that convert organic waste into liquid fertilizer products. These silage systems provide environmentally sustainable waste management while producing valuable agricultural inputs that improve soil health and crop productivity. The processing of mackerel bones and scales into calcium-rich supplements utilizes specialized grinding and separation equipment to produce pharmaceutical-grade calcium products. These materials command premium prices in dietary supplement markets while demonstrating the comprehensive utilization possible when processing operations are designed around complete resource recovery. Even the water used in mackerel processing can be processed to recover valuable proteins and minerals. Modern water treatment systems utilize filtration and concentration technology to extract dissolved nutrients while producing treated water that meets environmental discharge standards. Some facilities have invested in systems that convert organic waste into biogas for powering processing operations. The comprehensive utilization of mackerel processing byproducts requires sophisticated equipment and specialized knowledge of multiple markets. Oil extraction systems, meal production equipment, and waste processing technology represent significant capital investments that contribute to both economic efficiency and environmental sustainability. Quality control for mackerel byproducts maintains the same rigorous standards applied to primary food products. Fish oil undergoes purity testing and fatty acid analysis to ensure it meets specifications for pharmaceutical and nutraceutical applications. Fish meal is tested for protein content, digestibility, and microbial levels to ensure it meets animal feed quality standards. The markets for mackerel byproducts continue expanding as new applications are developed for these materials. Research into marine-derived compounds for pharmaceutical applications, biodegradable packaging materials, and specialized animal feeds creates new revenue opportunities for processors willing to invest in specialized processing equipment and market development. The economic impact of byproduct utilization can represent 30 to 40% of total revenue for well-managed mackerel processing operations. This additional income stream helps offset processing costs while contributing to environmental sustainability through comprehensive waste reduction and resource utilization. When it comes to culinary applications and nutritional value, mackerel represents one of the most versatile and nutritious fish available to consumers, supporting a diverse range of food products and preparation methods that span cultures and cuisines worldwide. Mackerel offers exceptional nutritional density that makes it one of the healthiest protein sources available to consumers. A single serving of mackerel provides over 25 grams of high-quality protein while delivering one of the highest concentrations of omega-3 fatty acids found in any food source. These essential fatty acids contribute to cardiovascular health, brain function, and inflammation reduction. The nutritional profile of mackerel includes exceptional levels of vitamin D, vitamin B12, and selenium, nutrients that are often deficient in modern diets. Mackerel provides more vitamin D per serving than most other food sources, making it particularly valuable for supporting bone health and immune system function. The high vitamin B12 content supports nervous system health and energy metabolism. Different mackerel species offer varying nutritional and culinary characteristics that suit different preparation methods and cultural preferences. Atlantic mackerel provides the richest oil content and strongest flavor, making it ideal for smoking, grilling, and traditional European preparations. Pacific mackerel offers milder flavor that works well in Asian cooking styles and canned product applications. Fresh mackerel preparation methods emphasize techniques that preserve the fish's natural oils and delicate texture while managing its relatively short shelf life. Professional kitchens utilize specific handling and cooking techniques that maximize flavor while ensuring food safety. The high oil content requires careful cooking methods that prevent the fish from becoming greasy or overwhelming in flavor. Canned mackerel represents one of the most economical and convenient ways to access the nutritional benefits these fish provide. Modern canning processes preserve most of the nutritional value while creating shelf-stable products that can be stored for years without refrigeration. Canned mackerel provides the same omega-3 fatty acids and protein content as fresh fish while offering greater convenience and affordability. The processing methods used for different mackerel products significantly influence their nutritional characteristics and culinary applications. Fresh fish maintains optimal texture and flavor, but requires careful handling and quick consumption. Smoked mackerel develops complex flavors while preserving nutritional value and extending shelf life. Frozen mackerel sacrifices some texture quality, but provides extended storage capability and year-round availability. Mackerel's role in global cuisine reflects both its nutritional value and cultural significance across different regions. Mediterranean preparations often feature mackerel grilled with herbs and olive oil, while Japanese cuisine prizes mackerel for sushi and sashimi applications where freshness and quality are paramount. Scandinavian traditions include smoking and curing methods that preserve fish while developing distinctive regional flavors. The development of value-added mackerel products has expanded market opportunities while making these nutritious fish accessible to consumers who might not otherwise purchase whole fish. Products like mackerel pâtés, spreads, and prepared meals utilize processing techniques that preserve nutritional value while providing convenient preparation methods. Research continues to reveal additional health benefits associated with regular mackerel consumption. Studies suggest that the omega-3 fatty acids in mackerel may support cognitive function, reduce inflammation, and contribute to cardiovascular health. These research findings continue driving demand for mackerel products in health-conscious markets. From an environmental perspective, mackerel fishing represents one of the most sustainable approaches to marine protein production, demonstrating how well-managed fisheries can provide abundant, nutritious food while maintaining healthy ocean ecosystems. The environmental sustainability of mackerel fishing results from the natural abundance of these fish combined with sophisticated fisheries management practices that ensure long-term population viability. Mackerel populations are among the most resilient marine species, with rapid reproduction rates and adaptable feeding patterns that allow them to maintain healthy population levels under proper management. Modern fisheries management utilizes scientific research and reappraisals